Hello, this time we're going to have another example, but this time on the theorem about the limit of cosine functions. Let's take a look at this. So we have the following theorem. Let's use my pen here. So the theorem says that the limit of one minus cosine x all over x as x approaches 0 is equal to 0. So we're asked this time to evaluate the limit of 1 minus cosine x all over sine x as x approaches 0. So we're interested in trying to make use of this limit theorem. Notice that again, as long as x is not equal to 0, we have if x is not equal to 0, then we will have 1 minus cosine x all over sine x is equal to, can rewrite that as 1 minus cosine x all over x all over, so we divide it, we multiply it by x over x, the entire thing, sine x over x. So that the limit now of 1 minus cosine x all over sine x as x approaches 0 is equal to the limit of 1 minus cosine x all over x all over sine x all over x, this time as x approaches 0. But that is the same as take the limit of 1 minus cosine x all over x as x approaches 0 over the limit of sine x all over x as x approaches 0. Now we have a theorem for this that is equal to 1. That is equal to 0. And we have a theorem for this one earlier, and that is equal to 1. So meaning to say that's equal to 0. Therefore, the limit of 1 minus cosine x all over sine x as x approaches 0 is equal to 0. Okay, so let me just write down again the theorem which we discussed earlier prior to this example, that is the limit of sine x all over x as x approaches 0 is equal to. So from there, from these two theorems here, from these theorems above, we have to follow